So here I'm messing around with the intercooler sprayer system for my Subaru 2.5 RS that I swapped several years ago. It's got a STI swap. I bought the iWire intercooler splitter, and I got his sprayer nozzles right there. This reservoir came out of 04 to 07 STI. I want to put it in my trunk, and I want to be able to spray water onto the intercooler. So I've been going through the wiring. I think I got everything hooked up and working right. I'm just gonna go over it to help other people. So the US car that we have, they have a momentary intercooler button. It looks just like that. And basically you push that in and it will trigger a timed relay, which is right here, that'll operate for 2 seconds, and it'll spray water on the intercooler. There's no fail-safe or anything like that for the button. There is a sensor in the bottom of the reservoir with a little float, and when the float gets all the way to the bottom, it will trigger a light on the gauge cluster to let you know that it's out of water, but there's no safety mechanism. If you push the button, it's going to try to spray even if there's no water, but it's not a huge deal because the person's not going to do that, and they'd have to continue pressing it for a long time to ever burn out the pump. So the US diagram's pretty basic. It's just the switch, the timer, the sensor in the bottom of the reservoir that senses when it's empty, and then the motor. Over in Japan, the JDM system is a little bit more advanced. They have an extra switch. Right here is the auto switch. And they have the ECU that is going to factor in stuff like the coolant temperature, the boost, the RPM, intake air temperature, and it's going to take that information, and if the auto switch is engaged, it's going to spray water automatically on the intercooler. And that is going to take advantage of the low level sensor. If there's no water in the tank, it's not going to automatically spray, because you could have it enabled and be out of fluid and boosting and getting on it, and you may not realize it. It still will trigger the dash light just like the manual operation. You're able to also press the manual button if you want it to spray. And both of them, even the automatic system, still goes through this timed relay. So technically when the JDM ECU says stop spraying, it's going to continue spraying for 2 more seconds. So the JDM diagram is a little bit more complex, and we can't exactly put it as is on the US car, because our ECU, which is shown right here in the diagram, doesn't have the capability to signal this under the certain RPM and coolant temp factors. But what we can do is we can get rid of this, and we can replace it with a Hobbs switch. So this is a Hobbs switch right here, and basically all it does is it hooks up to your manifold, and when it sees X amount of pressure, it's going to show continuity across 2 pins. It basically completes the connection. And these are adjustable. I don't know if you can see it, but there's a little Allen head key right there. I think this one only goes up to 15 PSI, if I recall. I had it laying around from a different project, but they do make them that go higher. But I'm just using this one for now for proof of concept. So when that sees X amount of boost, it'll tell the ECU to go into auto mode. So if we eliminate the ECU, we're also able to get rid of this diode that was in the JDM diagram. The diode is there just to protect feedback into the ECU. So we can get rid of that. The other thing that we can kind of get rid of is these connectors. This JDM diagram just shows every connector in the car. We don't need to put connectors there. We'll just use wire. So when you do that, this is what we're left over with, and I'll put a link to this. It's the same diagram, it's just simplified. I've removed the stuff that we don't need. I've also removed the pin diagrams from the bottom that we don't need. So these pins that you see at the bottom as if you were looking into the male end of the plug. So for instance, it'd be like you're looking at the plug just like this, facing right at you. And if you look closely, like you can see right here is a I-43 connector that goes into this relay. And then if you look down here, you can find that in the bottom left, we've got the I-43 connector, and that's as if you were looking right at the male connector. And it labels all the pins for you. It even has kind of the color code, like RW is red with a white stripe, GR is green with a red stripe, B is black, L is actually blue. They had to use a different letter because B is for black. But everything is color coded, but chances are that you're not pulling this system out of a JDM car. You're probably going to be building the wire diagram as is, so the color is not too important. So I've gone ahead and I've set everything up here, and I've got it working. I'm just going to kind of walk through what it does in each scenario. So flip over here. So the relays that I'm using are actually out of the Subaru. It's out of the car that I did the swap with probably 6-7 years ago actually. I just had them laying around, but you don't have to use Subaru relays. You could buy one from the store. Like this is just a generic relay that you can probably find at Advanced Auto or Amazon. They're like $2 or $3. So in the JDM diagram, there's actually a 4-pin relay and a 5-pin relay. There is a difference between them, but you could buy one 4-pin, one 5-pin, and you'd be fine. You could buy 2 5-pins and be fine. You just wouldn't use one of the pins on one of them. And how the relay works is we've got usually 12 volts coming in to pin 30, and there's this switch inside the relay that gets activated by this other coil. So when power goes through this coil, it creates a magnetic effect which will drag the switch down to here. So when the relay is engaged, pin 30 will connect to pin 87. When it's not engaged, pin 30 will connect to 87A. So that's pretty much how a relay works, and Subaru uses that to help with preventing the auto mode from working when there's no fluid in it. So if we look up here, here's the intercooler sensor. It's going to detect when there's no water in it, and one end, if you followed it all the way down, goes to ground. So when it's out of fluid, this wire right here is going to be ground. If you follow it all the way over, it goes to pin 2 on this relay. So relays don't have to output 12 volts when power goes across that coil. Most of them do output 12 volts, but you can also send in ground. So when this relay is activated, instead of completing this switch right here and passing 12 volts through it, is actually going to be grounding something. Because if you look right here, this is what is coming in, and you follow that all the way out here, it goes all the way down, it goes to ground. So when this coil is activated, this right here is where the connection is going to be. So ground is going to be going out pin 4, which goes to the combination meter. So that means when this level sensor on the intercooler tank is activated, it grounds the other end of this coil, which is hooked to 12 volts, causes the internal switch to be flipped here, which causes the ground to go through the connection, which grounds the combination meter for your low on water light that you see on the gauge cluster. When you have water in the tank, this coil isn't going to be active, so the switch is actually going to be over here. So we're going to end up grounding pin 5 of this relay. If you follow it all the way down, this goes to the automatic switch. So when you ground this pin, it does two things. First, it completes this light right here, so there's a light on the switch that will come on if the switch is pushed in. And it also causes pin 3 to be grounded as well. And if you follow pin 3 all the way up, goes all the way over here, goes up, goes over, that goes to the hob switch. And if the hob switch, if you're in auto mode and your light is on the switch because it's pushed in, and your hob switch is activated, meaning you're above whatever you have it set to, if you're above 15 psi, it's going to complete this connection. It's going to go into this relay. It's going to activate this coil. It's going to complete this connection, which comes all the way up to the timer, and the timer's got to go all the way back to the motor, and it's got to spray water. So it's kind of clever how they do a ground trigger for that relay. And if the tank is empty, it causes the light on the cluster to work, but when the tank is full, it grounds the auto switch. So I'm going to have this diagram available, but I'm going to go through just a walkthrough because I got everything hooked up here. So I just added power. So right now, this light is going to indicate the pump motor running, just because I don't have the motor hooked up right now. And this rocker switch is going to simulate the fluid sensor. So if I flip it one way, it'll act as if there's no fluid in the reservoir, and the other way will act as if there is. And then you can kind of see it down there. There's a light that's simulating the gauge cluster. So right now, this right here is the manual switch. So I'm going to press it, and you can see that light goes on for 2 seconds and then comes off. So that is activating this relay, and that light comes on. It has no bearing if it thinks it's out of fluid or not. And you can see when I flip this to simulate that I was out of fluid, the gauge cluster light came on. So if the gauge cluster light is on and it thinks it's out of fluid, pressing this auto button is all the way out, is all the way in. There's no light or anything coming on. So if I had fluid in it and I press this in, now you can see it's got the light that's on. So auto mode is engaged, and if the hob switch had enough boost pressure into it, it would tell the intercooler to spray. And I can simulate that right here. It's a little tricky because I didn't have another switch. But this is simulating the hob switch seeing pressure. So I'm going to touch this. You can see it would be spraying right now. I let off the gas pedal, and I'm no longer at that threshold. It's off. You heard it click, and then there's a 2-second delay. So again, 16 psi, seeing it. I'm going to let off it. See it's still there. After 2 seconds, it goes off. While in auto mode, I can also tap the manual button, and also it'll spray for 2 seconds. and out of fluid. You saw that the auto mode was on, the button's still pushed in, and it's not engaged. My Hobbs switch can still sense that I have above 15 psi. It's not gonna spray, it's not gonna engage anything because it's out of fluid, and that light will stay on until I add water to it. So that's more or less it. I'm gonna get this wired up and put in the car eventually. I just gotta make a mount for the tank and clean up the wiring. Obviously, I'm gonna have to make it a lot longer and run stuff to the trunk. But hopefully that helps.